Hello everyone. In today's video, we are going to analyze a continuous beam and we will show the shear force and bending moment diagram. In this continuous beam, we have a 45 kilonewton UDL and two concentrated load, one of 80 kilonewton and one of 25 kilonewton at the distance of given distance. We will do these analysis using the Staad Pro software. Here first, this is the Staad Pro interface. Here you have to select the new project. Just click on new project, select the space, given the file name continuous beam. Here you can select the unit which you need. Here in meter, kilonewton, as click on next. Here you can see the add beam. Just select it, finish this. You can see the Staad Pro interface. Here you can just create this. If you see, this is an XYZ plane. Here you can change the grid if you need. Here you can see, as per our question, we have the length of 6 plus 2 8 plus 8 and 3 11 and 12 meter. Here we can see the length is 12 meter, but here in the Staad Pro you can see it has only 10 sections. That means this is the 10 meter distance, so we need to increase the distance. Here just go to go and edit and increase this in 20 and click OK. Here you can see now we have the 12 section. Now first, this is the first point, first origin. First is 6 meter, here 6, other one is 2 meter. You can see this is 2, other one is 3, and here you can see the whole distance. Just close this. Now here you can see this span. Here you can see this is the beam. This is the two-dimensional direction which we have seen. Now click on general to assign the properties of the. Here you can assign all the things, support, all these. Here in software we provide the load, support, specification, property. First we will assign the property, which kind of material we are going to use. Just go on define. Here you can see we have different properties like circle, rectangular, trapezoidal, journal, tapered tube. It's just click on the rectangle. We are going to provide the rectangular. So the size of beam, the width is 0.45 meter and the width of the is 0.23 meter. Just add it and close this. Here just go and assign to the view. Just click on this. Here you can see this has been assigned to the view. If you render in the 3D view, you can see the section. If you want to see the whole beam, here you can see. Now we are going to assign the support. Here in this we can see we have one fixed and two roller supports. Here you can see the fixed support has been assigned. Now select the other one and select the other node and Here you can see we have assigned the fixed support. We have assigned those pinned support also. Now we are going to assign the loads and definitions. Here in the load and definition, here you can see define the loads if you need. Just click on load case detail and just click on add. First we are going to add the dead load. With the live load, you can just provide the live load if you need the. Just click on add. Here you can see that the live load has been added here. Just go and live load, click on add. Here you can see first we will here load. First go on the member load. First we can see the uniform UDL is of minus 45 kilonewton. Here you can find minus 45. Just go ahead when we have, and we have the two, one is 80 and one is 25. Is minus 80 kilonewton and other one is minus 25 kilonewton. Now just go and edit. Just provide the distance. Here you will the distance. On the loads, here you can see these are those. Now we will assign those loads. Just click on this beam, assign to the selected beam, and assign this. Just go and assign this. Here you can see the load has been assigned to. Here you can see the. Now select this beam and just go on this concentrated load and assign to view. Now here you can see that the load has been assigned. Select this and select this. Assign to the selected beam. Here you can see that the load has been assigned here. If you just do this, here you can see this is the UDL, this is the point load, and this is the last concentrated load. Now if you want to, now here we can see the UDL in the point load and this concentrated load over here. Now if you just go on the label to see the load, loads and result and other. Click on the load value, just click on apply, and okay, here you can see the load value assigned. This is 45 kilonewton, this is 80 kilonewton, and if you want to see the distance, just click on this, and from here you can just find out the distance from node to node. Here you can see this is 6 meter, this is 5, and if we want to see this, and this is 1 meter distance. If as of the diagram, you can see here from here this is 6 meter, 45 kilonewton concentrated load. Here you can see the 80 kilonewton at the distance of 2 meter. If you find this distance, this will be the 2 meter. If you just want to measure the distance, here you can see this is the cut section, this is the dimension measurement and dimension to view. Just go from here to here. If you want to measure the distance, you can just measure this distance also from here. you want to save the picture, you can just click on this picture and click OK. You can see, and now we have model and assign the value in the consent. Now we are going to analysis the software, and just click on analysis. Just click on all. If you need load static and static, if you need, you can just click on add. Here you can see we have add the command perform. Just go on analysis, click on run. It will ask you to do the save the project. Just save the project. Now here we can see, now if we want to analysis, just click on the analyze and print. It will ask you to add this. Just click on add. Here you can see, here you can see all those things. It will ask you to perform the analysis. Just close it and click on analyze. Here you can see if you have no error, it will show here error, any warning. Here you can see I have one warning, 0 error, and warning is nothing. You can just view the output file. From here you can see what warning is. It is showing the consecutive analysis command only first use. That's it, nothing. We have just performed 2 time analysis, that's why it's asking. Here you can see number of joints are 4, number of members are 3, number of supports are 3, total primary load. Here you can see all those things which we have provided, the dimensions, the values, all those things. Now if we want to design, here you can see we have no error. Now if you want to design, here you can see, and after the analysis part is over, if you want to see the bending moment, just click on this post processing, just click OK. If we need to see, just click on this. Here you can see the bending moment. This is the bending moment diagram. If you want to in y direction, here you can see, if you want to see the torsion, there is no torsion provided. If we want to see the shear force, here you can see the shear force diagram of this continuous beam. If we want to shear force in z direction, there is no shear force in the z direction because we are doing this in x plane. Here you can see this is the shear force value and this is the bending moment value of the diagram. If you want to save this, just click on the take picture. If you want to see these displacement and other, if you want to see the values of, just click on result and click on this view value. Here you can see the beam result. Here if you need the shear force at ending, maximum, midpoint, here you can select and note the shear force must be. Here you can see the shear force. If you want to see something, just go on this new value. Here it is showing at the end, maximum, midpoint. If you want to see the bending, just close. Here you can see the bending moment. If you want to see the shear force, you can just, here you can see the shear force. Here is 0 and maximum at 142.649 kN. To see the report, just want to see the report. Here you can see the report also. You have the beam section, material support, which we want. We can just see those reports also. Just provide the input, output. Here we need this pictures and just click. We have 2 pictures over here. You can just select those pictures and assign to them here. Here in the output, what we need. Here just here we are going to see the 3 internal. Here we need the maximum bending moment. Just search for this maximum bending moment, maximum shear force and beam displacement summary. Here you can see this is the beam and display summary. Okay, beam and force summary, displacement summary. Just select this. Apart from this, you need to select the beam maximum moments. Beam, here just go up. Here you can find the beam maximum moment and beam maximum shear force. Here you can find the beam maximum moment and beam maximum shear force. Just select all those. Here this is the job info, what we have provided. This is the picture. Just click on OK. Here if you want to save this, we can just save this. Also just click on print and save this as Adobe PDF. Where you want to save, you can just save this file. Here you can see what is this, what we have provided. If you just open the Adobe file, you can find all those things. Here you can see on which date it has been corrected, what is this, what number of nodes provided, highest beam, and here you can see the diagram, what kind of load has been provided at what distance. Apart from this, you can find the shear force and bending moment, and in the beam summary you can find where is the maximum, what kind of load it has been provided. Here you can see the maximum load, where is the bending moment is maximum, at which point. This is the maximum shear force provided over here. That's it from today. Thank you for watching, and please kindly subscribe the channel if you find the information useful. Thanks for watching.